Well, I'm back to looking at this Hallicrafters SX62A, and I thought I might do a little housekeeping before going into what I intend to do. This is a book by Chuck Dacus that's available. I think there's a newer edition than this one. I've had it a few years now. I think Chuck is probably the most prolific collector of Hallicrafters, at least that I know of. And it's a great book. It's not on servicing, it's on the actual Hallicrafters receivers and so on. And for example, there's the SX62. I also have an SX71 that maybe someday I'll do some restoration on. But anyway, that's a pretty good book for people who just want to go through like I love to and look at all the old receivers and what their specifications were and so on. Second thing, more in line with where I'm going to be going today, I put together a little bit of an oversized schematic. And while I realize that there probably is going to be some difficulty with people reading this, I thought it still might be helpful to have this both for myself and for viewers. But I recommend that if you really want to follow along on these videos, particularly from this point forward, that you download the Hallicrafters material from at least the BAMA website. BAMA stands for Boat Anchor Manual Archive. And if you just type BAMA manuals into your browser, you'll find it. And then just go to the Hallicrafters section and look for the SX62A. What I'm going to be doing today is I'm going to be basically testing the tubes and that power transformer. And by that, what I mean is I'm going to be pulling the tube out, testing it in a tube tester. You may remember in part 1, I already tested the 5U4, the rectifier, and I've pulled it out. It was in that socket there. As I pull tubes, I'm also probably going to brush off the chassis a little bit, get rid of the accumulated dust, and fortunately there doesn't seem to be too much rust on this chassis, but if there's any rust I may get rid of that too. So this will be kind of a herky-jerky process. But before the end of this video, what I hope to have done is tested every one of the tubes in this receiver to see if it generally is good. In other words, the filament's good, it has reasonable emission and things like that. That doesn't mean they'll work in the circuit, but it does mean that we have a better than even chance of getting things working. Most of the problems in old radios like this, and old TVs for that matter as well, we'll find in components like capacitors, especially electrolytic and paper capacitors. There is a possibility that you'll have a bad tube, although not nearly as often as a lot of people believe. And finally, you can have a lot of mechanical issues. There are some esoteric little things that can crop up, like a capacitor now and then get noisy or go bad. Those things don't happen very often. Generally, if you have decent tubes and if you replace most of the capacitors in these old sets, you'll find that you can get them working again with very little additional trouble. They often do need alignment, so one thing you may need is an RF signal generator that's reasonably accurate, but those can be had on eBay for very, very little. So anyway, if you're getting started in this, I suggest you follow along, download the SX62A manual from BAMA. It's in several different formats, and you have Deja Vu and PDF and so on. So let's move on now, and the first tube I'm going to test is this OD3. If the tester will do it. I haven't checked to make sure that my tester will test these. This is a voltage regulator tube. And what I thought I might do is, as I'm going through the schematic, or pulling the tubes, I point out in the schematic where that tube is and basically what it does. I've already talked about the 5U4 rectifier and the fact that it, in conjunction with this transformer, is what produces B plus in the set. The high voltage winding connects to each of the two plates. The filament is also the cathode. In other words, it emits the electrons. It not only gets hot, but unlike some tubes where they have indirectly heated cathodes, this one is directly heated. And so I've already tested the 5U4, but before I'm through today, what I hope to do is to test all of these windings to make sure they're putting out the right voltages. But I'm going to do that with this tube left out. So let me get on and see if I can test this voltage regulator tube. And by the way, these, you don't find these very often. Only in the very top end sets of the era do you find voltage regulators. They are like Zener's, but if you've watched the video that a fellow named Mr. Carlson did on Mr. Carlson's lab, comparing voltage regulator tubes to Zener's, you'll find that these are actually better than Zener's. But I'll let you watch that if you doubt or would like to know more. So let's pull this out and see what it tests in the circuit. And if the tester won't test this one, what I may do is save this and try it on my Hickok. I'm certain that the Hickok will test this. The OD3 is also known as the VR150. Well, as luck would have it, the first tube I tried to test, which is this VR150 that goes over in this socket, won't work in my tube tester. Now, I do know that the Hickok tester will test those. One reason that I suspect mine won't is that's a cold cathode tube, and the tester that I have, I think, is just not wired up for that. So we'll save that one for now, and we'll move on to the next one. The next tube that I'm going to test is the audio output tube, and in this set it has a push-pull audio output, two 6V6s. In order for this push-pull to work, and you notice that the plates are connected to opposite ends of the transformer, but for that to work you need to have the grid signals 180 degrees out of phase. So in other words, as this tube is conducting more, this tube is conducting less, and vice versa. And that produces what's called push-pull. It helps to reduce distortion. It also provides more power output, but it requires a tube or a transformer to produce this 180 degree phase difference. And those are often called phase inverters. At any rate, that's what this tube is, which we will look at next. But for right now, let's take a look at the two 6V6s that produce the audio output. Okay, this is the 6V6. I took it out of this socket here. That's the VR150, and to orient you, that's where I took the 5U4 out. These are the two 6V6s that produce audio output. And in case you're wondering about my method here, I generally tend to work from the power supply to the audio section, and then through the detector section into the IF, and then from the IF into the RF section, and so on. And part of the reason for that is that lets you test things that are downstream. So for example, I hope that when I start powering this unit up and get capacitors replaced and so on, the first thing I'll do is I'll apply an audio signal and see if I can get an audio output. Now, one thing that I'm going to have to do is, this is a speaker that I'm hoping to use on this set, and I'm eventually hoping to build it into an enclosure that simulates what the old Hallicrafters enclosures were. To be honest, the Hallicrafters speakers always sounded pretty tinny. They were in metal cabinets, and even the big 10-inchers like the one that came with this set, they produced reasonable bass, but the highs were pretty tinny, and the metal often resonated, and anyway, it didn't sound very good with if you were playing something like music on it. It worked okay for voice. At any rate, let's go ahead and test this 6V6. I have tested for leakage, and I did find some leakage on a couple of the pins, so I want to be aware that that might be an issue. But I'm going to let this warm up a little bit. And then down here in the tube listing, you see the 6V6 says it's a D2, and the plate is 5 with a load of 30. So we'll set the load to 30, and then we'll press 5, and it looks like we've got reasonably good emission in this tube. Once again, as I point out, this isn't the best way to test a tube, but given my experience, and I've been doing this since the 50s, that doesn't make me an expert. It just means that I've made a lot of mistakes. But my experience is that tube testers never really tell you whether the tube's going to work in the radio or the TV. They just tell you if it's completely dead. Of course, that's a good thing, but or a bad thing depending on your point of view. But at least you know. Unfortunately, no matter what you test it on, the most expensive tube testers in the world will not tell you that it will necessarily work in a particular circuit. So this just is a way to sort out the really bad tubes, and right now this 6V6 is definitely not one of those really bad tubes, so I'll put it back in. I'll test the other, but to save time I won't video that. The next tube that I'm going to test is this dual triode. It's a 6SL7. They call it the audio inverter, but what they mean by that is it takes the audio signal, single-ended, and converts it into 2 audio signals 180 degrees out of phase to feed the push-pull 6V6s. So let's go over and test it on the tube tester. And by the way, another reason that I like to do this with a set that I haven't worked on before, that is pull the tubes, and here's the tube, it came from that socket over there, is that it allows me to make sure that the tube number actually matches the socket that it's supposed to be in. I can't read the 6SL7 on this one very easily. Oh, there it is. Maybe we can see it. Well, take my word, it does say 6SL7GT on there. So let's put it in the tube tester and set up the tube tester. See whether this tests good or not. On this tube, the 6SL7, I'm going to show you how you test for leakage on a tester like this. And in general, I'm going to eliminate this step in the videos, although I still do it for each tube. You set the tester up as per the instructions, and then you push the tube selector to leakage, and then you go through and you slide each of these switches from the neutral, that is the end position, to the P position, which is the plate position, and you look for leakage on this AC leakage indicator. So I'm going to do that. This is 1, and a flash is good, but a steady is not. So 2, and you notice there's some leakage indicated. 3, some more leakage. 4, leakage. 5, leakage. 6, leakage. 7 is the filament, so you do not move that one. And so the last one is 8. And there's leakage on there too. Now the 8 would naturally show because that's the other side of the filament. So now I've tested for leakage. I should point out that this particular tester has an unusually sensitive leakage circuit, and so the fact that that light comes on dimly may not really mean that there's anything wrong with the tube. So let's now move the tube switch down to the quality position, and as we see in the listing for the 6SL7, the plate pins are 1 and 4 with a load of 30. So we go up here and flip 1 to the P position, and we get good indication. And then we do the same for 4, and another good indication. Well, you're probably getting the point here, so what I'm going to do is speed up this process, and for the next some number of tubes, I'm just going to show you where they are in the schematic and then how they test in the quality position. Here is an example of what I was talking about the right tube being in the right socket. I just pulled this tube from this socket, and it's clearly labeled a 6C5. When I look at the tube, it's V10. At the tube chart for V10, the CW beat oscillator, it says it should be a 7A4, which is a loctal tube type. And when I go to the schematic, it says the CW beat oscillator should be a 6J5. So I suspect what I've got here is a run difference. That is, the run of SX62As that this one came from. They had made a production change, and we're using a 6C5. What I'm going to do is I'm going to note that difference on this tube chart right there, and then I'm just going to go ahead and test this 6C5 and put it back in that socket and assume that that is correct. And then later, when I get back in the house and have the rest of my reference materials in front of me, I'm going to see if there is a run that used a 6C5 in that position. I suspect that's all that's going on now. Okay, now we'll test the 6C5, and I'll go to pin 5. And I wanted to do this deliberately to show you. I've just turned this tube on. Watch the meter. It's swinging up. Of course, what's happening is that the filament is getting warmer and warmer and producing more and more electrons. So you want to be careful when you're doing either emission testing, or especially when you're doing mutual conductance testing, that you always let the tube come to its normal operating temperature. And as you see, when it does, it's in the green scale for good. So the 6C5 is a good tube, and I'm assuming at this point that that is the tube that's supposed to be in that socket. But like I say, when I get to my reference materials for the other SX62 line, I'll check that and see if there was a run where there was a change made to that particular circuit. I put the 6C5 back and went to check on 6J5s and 6C5s to see first if there's any mention of a 6C5 in any run of the Hallicrafters SX62, 62A, or 62B. And the answer is I couldn't find any. I don't think any exist. I looked through a total of about 12 manuals and a couple of other reference sources, Ryder's, Sam's, Hallicrafters original manuals, and so on. Anyway, I don't think they ever used a 6C5 in an SX62 BFO, but the 6J5 that you see here and the 6C5, it turns out, are pin for pin the same. They're both medium U triodes. They draw the same filament current, and they have the same maximum plate voltage and things of that sort. So I decided to see if I could find any place that says that you can substitute one for the other. Eventually, in a Howard W. Sam substitution guide, it shows that a 6C5, there we are, that a substitute for a 6C5 is a 6J5. What's interesting is the reverse isn't true. That is, if you look up a 6J5, it does not say that a 6C5 can replace it. So there is still some issue about whether that tube is going to work in this SX62, but for now I'm going to leave it in there. It's not correct, and eventually I may replace it with the correct 6J5, especially if I have any trouble with the BFO, the what they call the CW oscillator, or hams call it the beat frequency oscillator. It's at any rate. However, one of the pluses of all of that is I wound up printing out a number of tube diagrams, that is the arrangement of tubes in various versions of the SX62. So I'll be using those a little more too. But I thought I might do this. I realized I also reviewed the video that I had shot in the early part of this part 2, and I realized that first, it's running a little long. Second, there seems to be a loud rumble, and I think I know what that is. I don't hear it. We live on the top of a hill, and on one side of the hill is a road that is not used very much for commercial traffic, but occasionally there's a quarry that's located several miles from us, and occasionally the dump trucks from that quarry use that road that goes about a half to 3/4 of a mile down the hill from our house. So anyway, I apologize for those rumbles. I think those are the dump trucks. I don't actually hear it while I'm recording, but later when I review it, I notice how annoying that rumble can be. So I think what I'm going to do is I'm going to just go through the rest of the testing without doing a lot of video on that. If I see anything that's a bit unusual, like a tube out of place or a tube that doesn't test well or something, I'll put that on the video. But otherwise, I'm going to kind of cut to the chase here and try to wrap up this video fairly quickly with maybe one more segment or so. Well, there is one slight anomaly here. When I was testing the 6H6s, there are 2 of them in this receiver. They're that little bitty squat tube, octal socket, and you'll notice that I have pin 5 here set to the plate position. It's got pretty good emission. The pin 3 should have the same. You'll notice that it's right on the border. Now, not only is that questionable, but I noticed that pin 5, the emission came up into the green right away. I mean, within about 4 or 5 seconds. It took this section, it's a 2-section tube, and I'll show it to you in a second. It took this section a good 30 seconds, maybe 45 seconds to get up into that region. I'm going to turn this off, but leave it all connected while I show you in the schematic and let that tube cool down just a little bit. The 6H6 is used 2 places in the SX62. One is here as the FM discriminator, and by the way, I don't know if I ever pointed out, this receiver will receive from, I think it's about 530 kilohertz all the way up to about 109 or 110 megahertz continuous. It'll receive AM, it'll receive CW, and it'll receive FM. But I believe it will only receive wideband FM. And this is the discriminator that is used to produce the FM, or demodulate the FM signal. The 6H6 is also used over here as a noise limiter. Once again, I'm not going to go into the details of these circuits, just the general purpose. However, because this 6H6 looks like it's a little bit slow to warm up and never does really reach the emission of its brother on the other side, I think what I'm going to do is put this one in the noise limiter circuit, because that's not a circuit you use very often, and put the better one. The other one, by the way, came up right away and tested pretty good. This one seems a little weak on one side. So I've let it cool off a little bit. Let's retry it. We'll turn the power on, and then we'll switch pin 3, and we'll watch. You notice it's coming up. Well, it's coming up a little faster this time, quite a bit faster than it did earlier. But you notice that it hangs in that region. And even after 2 or 3 minutes, it barely makes it into the green. So those are the sorts of things that you sometimes run into, and you never know for sure if that's going to be a problem in the circuit or not. But nonetheless, this is the tests a little worse than the other one. So I'm going to put the better testing one in the discriminator circuit. But for right now, I'm just going to put them back where I got them, because I'll keep in mind that there is one that might be bad. And if I need to, I'll swap the two later. But it's not a good idea to be swapping tubes around, in part because that means that you're probably going to upset the alignment, particularly in circuits like this discriminator. The discriminator works at about 10.7 megahertz. In other words, it takes the 10.7 megahertz IF signal and converts it to audio. That's a high enough frequency that things like interelectrode capacitance and so on will change the alignment of the set. So you just want to go back to the tube that was in there until you can see that it's just not going to work. Then I'll go to the other tube. So charging on with more tubes. Well, it's happened again. I replaced the 6H6, these are the two I just tested, and then I pulled this tube, which the tube diagram says should be a 6SG7, and it's not, it's a 6SH7. So I'm going to test it, and once again, it turns out that in the manual, the SH7 and the SG7 are tested the same, but one reason I wanted to show you is, you noticed here that it says with the SG7 you have to put pin 3 to neutral, whereas with the SH7 it's pin 5. So I rather suspect that these are, I'm going to test it as an H7, SH7, so I'm going to put pin 5 in the neutral position. But usually when there's a neutral like that, it means that there's an internal pin or something connected to that pin that needs to be isolated when you're testing it. And so I'm going to have to look again and see if that's really a replacement for a 6SG7. And so it goes down the road looking more at the documentation and the tube manuals and so on. So let's test this one. The SH7 is a D2 with pin 5 isolated, and we use pin 4 at a load of 30. So we'll go to 4. Well, that looks like a test good, in fact really good, at least on emission. But because of that pin difference, I'm a little bit suspicious. So I'll have to check that one out as well. And again, same song, second, third verse, whatever it is. The second 6SG7 is also an SH7. Those two tubes are two IF tubes. They are the second IF and what is called the third IF, which the first IF is a 6K7 right here, and that is what's in that socket, is a K7. But it looks like the second and third IFs that are supposed to be SG7s, you notice in this the tube it says 6SK7 is the first IF, and then the second IF should be an SG7. In this particular one, it was the third IF used to be a 7H7, but I'm pretty sure that's a production change to a 6SG7. But in none of the literature that I've got does it show a 6SH7. So once again, I'll have to check that one out. Fortunately, as a tube, it tests pretty good. But once again, it has that one pin difference, be that the pin 5 on this one needs to be isolated. So let's test the next 6SH7, which is this one. By the way, you'll notice that the ones I've touched are the ones that are clean on top. So we'll take this one out and replace it with this one, and I'll be back in a second. You may have noticed when I was showing you the first IF and the second IF that I said they were both 6SG7s, or listed that way anyway on the tube basing. But this one is actually in the schematic shown as a 7H7, as that tube listing that I showed you earlier indicates. So this schematic, I think, is from an older run, and I may need to find a little newer schematic to work with, unless the 6H7 is a pin-for-pin replacement, or the 7H7, I mean, is a pin-for-pin replacement for the 6SG or SH7, in which case I can continue to work with this schematic and just remember that it's not the same tube number, although it's an equivalent type. Okay, let's go back over here and try this one. And it tests pretty good. So let's move on and test that 6SK7, the first IF amplifier. Remove the 6SK7. You may hear the airplane going over. My days of private piloting are behind me, but I used to love to fly about this time of day. It's late afternoon, early evening, as the sun begins to set. I just think it's the second best time to fly. The best time to fly is right at the very break of dawn, especially if you can fly away from the sun, and it's a foggy morning, at least not too foggy that you have to be on instruments, but enough that the fog is still in the low-lying areas. Well, enough about that. That's in the past. So this is the 6SK7, the first IF amplifier, and you see it works pretty well as well. It does not need any neutral pins. So it, once again, is not a pin-for-pin replacement for the 6SH7s. I think I showed you those two are right here. But the schematic says that I think they're supposed to be 6SG7s. So we'll let it go for now and come back to it. The next tube came out of this socket, and you may notice it's a little different. Up till now everything has been an octal socket. Now we're going to a 7-pin miniature. There's the tube, and it should be on pin 6. And by the way, this has 2 isolated pins. So we'll test pin 6. And that one looks pretty good. So that tube is used as the calibration oscillator, or the crystal oscillator. This produces a very accurate and stable frequency that you can use to calibrate the dial on the SX62. Once again, this is a feature that only the top-end receivers tended to have, at least certainly back in the day. And it's a far less critical circuit in general. As long as it will oscillate, it's pretty much guaranteed to oscillate at the right frequency unless you have a bad crystal. So it's not really sensitive to tube variations. Like I say, as long as the oscillator will start and run, it usually runs pretty reliably. So let's go to the next. Now we're on to testing the 6AG5, and this was a fairly hot tube in its day. You often could soup up a TV set in fringe areas by replacing the front end tubes with 6AG5s. They were pretty good tubes for the day. So let's test this one and see how it works. There's the emission, quite good. The 6AG5, and there are 2 of them in this set, go over on this side, and they are shielded. They are used in the RF amplifier. This is a very unusual design. The SX62 had 2 RF amplifiers and 3 IF amplifiers. So it had more tubes devoted to RF and IF amplification than most radios of the day had devoted to radio. In other words, if you took the rectifier, set it aside in both radios, you had the All-American 5 only had 4 tubes that did amplification. This set has 2 in the RF, usually none in the All-American 5, and generally in the All-American 5 there's only 1 IF tube. So they have 5 tubes here doing what in an All-American 5 only 3 tubes do. Or, I'm sorry, 1 tube does, just the IF amplifier. So that's one thing they could do because they had lots of money. these were very expensive sets in the time. So you may also notice that I'm starting, while I'm playing around here, I'm also starting to put in brush off, clean off the chassis a little bit, and that has an advantage. You, for example, can start to see tube lettering like right there. I don't know if you can see, it's upside down, but it says 6C4. You can see it from this way a little better. And similarly over here, that's a 6AG5, and so on. So that also helps you identify, and sometimes when you have a tube layout like this that doesn't match the set you're working with, you can rely more on the numbers stamped on the chassis. Lastly, while I'm doing this, I'll point out a few things that you should watch out for, or at least places where I've messed up in the past and learned from it. One is you always want to be aware of where there are little components like these little bypass capacitors here. They're very fragile. You don't want to be pushing around in there too hard with your fingers, or especially not with a tool. You can break those very easily, and they're a part of the alignment of the set. Similarly over here, you don't want to use a solvent anywhere near these trimmer capacitors. Some manufacturers call them compensators, but nonetheless, you don't want to get solvent down in those. It can permanently, what it does is it washes all the dirt down into the mechanism, and it's a devil of a thing to try to clean later. So don't use solvents, just use plain water. Be careful and don't use very much of it. But here I'm slowly but surely getting the grime off this chassis. I've now removed the 7F8, which is in this socket. And you may notice this is an unusual socket. This is an octal socket. It has 8 pins, just like an octal. It has a keyway, but instead of the plastic keyway, it has a metal keyway, and it locks into the socket. You may also notice that it has a 7 in front of it instead of a 6, and yet it only uses 6-volt filaments. In the day, it was one of these battles between radio manufacturers, and I think it was Philco, or it might have been Motorola. One of the manufacturers started this tube base, claiming that it was superior to an octal because it locked into the socket. Actually, the octals were perfectly fine. I never saw one that would shake out, maybe in an aircraft, but not in a car or a TV or anything. But nonetheless, it was a battle. But they couldn't use the 6-volt designations. They had to go to a 7 as the first digit. So don't be fooled. It's not a 7-volt tube. It's still a 6-volt tube. It's just when you have the 7, it means it's a 6-volt tube with a loctal instead of an octal base. So here is the tube that we're testing. Pin 1 and pin 8. It's a dual section. And now let's go put it back, and I'll show you the socket as I do that, since it's a little bit unusual. There you see the locking ring. So I'll put this back in, and then I'll show it to you on the schematic. Once again, you know, it's more of a marketing ploy than anything else. It really wasn't that much better than an octal socket, but you know how it is when you're in competition. And here is the 7F6 in the circuit. The left half is the mixer, which is the thing that converts the incoming frequency to the intermediate frequency. And the other half is used as an oscillator that converts, or is the signal that is mixed with the incoming signal to produce the IF frequency. So that completes checking the tubes in this set. I think what I'm going to do is defer doing the power up on this for another part. This one has gotten awfully long and probably very boring, so I think I'm going to wrap it up here and put this together as part 2. I hope you've enjoyed this and will join me for part 3.